Alright, in this problem we have a clock, and it's not a very good clock because it loses 12 minutes every hour. And we're told that the clock shows the correct time right now, and we're asked in how many minutes will it next show the correct time. Alright, well let's just start dealing with what we know. It loses 12 minutes, 12 minutes every hour, and 12 minutes I can divide by 60, right? Because in 1 hour we have 60 minutes, and then we know that 12 minutes is 1/5 of an hour. Okay? So that gives us some information because we might be interested in knowing how long does it take for it to lose a full hour. Well, you can tell from this if it loses 1/5 of an hour in 1 hour, how long is it going to take to lose a full hour? Well, it's going to take 5 hours, right? Because 5 times 1/5 is 1, right? So I'm just going to write that down. It loses 1 hour. 1 hour. It loses 1 hour every 5 hours. Okay. So we know that. And but you could also look at it this way. You could say, well, the actual time right now, let's make a little table. T actual and T clock. Okay. And so it's 3 o'clock right now, and the clock says it's 3 o'clock. So at 4 o'clock, what's the clock going to say? It's going to say 3:48, right? Because it's behind by 12 minutes. And at 5 o'clock, what's the clock going to say? It's going to lose another 12 minutes, so it'll say 4:36. Alright. And at 6 o'clock, what's the clock going to say? It loses another 12 minutes, so it's going to say 5:24. And at 7 o'clock, it loses another 12 minutes, so it's going to say that it's 6:12. And then finally, at 8 o'clock, the clock is going to say that it's actually 7 o'clock. Okay, so after 1, 2, 3, 4, 5 hours, it's behind a whole hour, right? Okay, so the other thing is that with a clock, every 12 hours the times start repeating themselves, right? So right now it's saying 3 o'clock, and in 12 hours it'll say 3 o'clock again. Well, if this were a working clock, this would say 3 o'clock again, right? So we want to know, essentially, how long will it take for it to lose 12 hours? Okay, because after it loses 12 hours, it's going to be back to where it to where it was before, right? So how long will it take to lose 12 hours? So it loses 12 hours every, well, 12 times 5, so that's going to be 60 hours. Okay, so after 60 hours, it's going to be back around to the same time again as the actual time. Okay, but we have to be careful because they ask for minutes. All right, so we've got to convert this 60 hours to minutes. Well, 60 hours times 60 minutes per hour, is just 3,600 minutes. Okay, and that's our answer. In 3,600 minutes, this clock will have lost 12 hours, and so in 60 hours or 3600 minutes, we're going to be back to the point where the actual time and the clock time match. Briefly. For for a brief time, and then it'll be off again, right? So that's our answer. 3600 minutes.